No, SI unit of velocity is meter per second, and SI unit of acceleration is meter per
So
second square.
acceleration meter per second square you told.
Yeah, SI unit of acceleration as meter per second square. Okay. So we will be discussing now uniformly accelerated motion, and then we will also discuss the kinematic equations representing the uniformly accelerated motion.
Yes, sir.
So our topic is kinematic equations of motion. Or we also call them as just equations of motion. They are also called as equations of motion. So, first of all, we will be discussing here mainly for uniformly accelerated. Uniform acceleration means the the object has a uniform acceleration. That means the velocity of the object changes uniformly. So in the last class, we had discussed that if the velocity of an object changes, we had also studied the difference between
Yes,
speed
sir.
and velocity. We had seen that the speed is a scalar
Yes,
quantity and velocity is a
speed
vector
is
quantity.
a scalar and velocity is a vector.
Yeah, speed is scalar and velocity is vector. Velocity is a vector quantity. Similarly, we have seen acceleration in last class. That acceleration is given by the formula final
So
velocity
P minus U by time.
by time. So this was how we represented acceleration. See, acceleration can be positive also, it can be negative also. What do you mean by a positive acceleration?
Sir, if the object is accelerating forwards and not coming backwards.
Sir, negative acceleration means in which initial velocity is more than final velocity.
Yes. A negative acceleration means if initial velocity is more than the final velocity, then we call it as a negative acceleration. For example, when you are riding a bicycle or when you are cycling and you apply the brakes. So when you apply the brakes, your velocity is less, but your initial velocity is high. So in such cases, we observe the acceleration to be a negative quantity. We observe acceleration to be negative. In which cases will acceleration be positive? If the velocity of the object increases uniformly, then acceleration will be positive. So acceleration has negative acceleration. If you have negative acceleration, it's also called as retardation. Also called a retardation. So I can say the vehicle is retarding. Retarding means its velocity is decreasing. If the velocity increases, so I will say that velocity is increasing. So acceleration is a common word. Acceleration can be either positive or negative. But if I say retardation, so it surely means a negative acceleration. In the similar way, we also use a term deceleration. Deceleration can also be called as negative acceleration. Okay. Now, for the first equation of motion, we have to correlate. Okay, just one more example here. Consider here two cases. In one of the cases, you are throwing a ball upward. Here, you are throwing a ball upward, and here you are dropping a ball downward. You dropped the ball in the downward direction, and here you threw a ball in the upward direction. So, in which case will you have positive acceleration, and in which case you will have a negative acceleration?
Sir, in which we
Sir,
throw
in
a
first
ball
case
from
we'll
up
have negative.
and down.
In which one we will have negative?
Sir,
Sir,
first
in the
one,
first one,
Yes, in the first one, we will have negative acceleration because the speed of this ball will decrease
sir, and the
as the,
final velocity will be 0.
yes. So here it is a negative acceleration, and here we have positive acceleration because the speed is increasing. When you drop it, its speed increases. So this is a positive acceleration. So
sir, I
for
have
the
a doubt.
first, yes,
Sir, means can zero occur in acceleration?
yeah, zero can occur
Mean,
in acceleration. Also, zero can occur in acceleration if there is no change in velocity. So at that time, it will have zero acceleration.
so can you give one example?
Okay. Suppose you have your cycle moving with a constant speed. So cycle
Okay.
moving with constant speed, and aeroplane moving with a constant speed. Such are examples of uniform motion.
Yes,
Okay.
So can acceleration be zero? Means it's actually um, um,
Yeah, actually it is zero when it is moving with a constant speed. If your bus is moving with the same speed of 40 km per hour or 60 km per hour, okay. So at that time the acceleration is zero. There is no change of velocity.
okay.
Okay, the velocity every time is same. And if the bus moves in a straight line, then only. If the bus changes its direction, then the velocity will change. Since velocity has magnitude as well as direction. Since the velocity
Okay.
has magnitude as well as direction, so therefore every time its velocity will, if the direction of velocity changes, then acceleration, then there is an acceleration.
Okay, sir, understood.
Understood? Okay. So now we come to the equations of motion. Equations of motion means, now how do we find out that how much time will this ball take to come to the ground? Since the speed is not constant. Okay, up to now we only use the formula speed equals distance over time. Okay, and using this formula we find out distance, time, and speed. But here we know that speed is not constant, its velocity is changing. So how do we find out that how much time will it take for this ball to come from the highest point to the ground? Or if I throw it with a certain velocity, so how much time, how much height will it go? Okay. So for finding out these things, to find out the displacement, to find out the time, we need equations of motion. So we have our first equation of motion. Here we have first equation of motion. It's given as, it's just a rearranged form of acceleration. So we have the formula of acceleration as acceleration given by v minus u over t. If you rearrange the term, transpose this t to the other side, you get here at equals v minus u. Okay. Then you transpose this minus u to the other side, you get here plus u and plus at equals v. So you have the equation v equals u plus at. This expression we call as the first equation of motion. So this expression gives us an idea to find out the final velocity. If an object is having a certain acceleration, so this gives us an idea to find out the final velocity of an object. So let us do one question over here. Can we do a question?
yes, sir.
Yes.
Yes, sir.
So see, Find the velocity attained by a vehicle if it starts from rest and has a uniform acceleration. Uniform acceleration of 2 meter per second square. Okay. So can you find out the answer and tell what should be the final velocity?
So what's the time?
Yeah, time is 2 meter per second square in 5 seconds. Okay. So I'm waiting for your answer.
Final velocity
Sir, 10 meters per second.
10 meter per second. Sir, 10 meter per second, right?
Okay. So final velocity will be 10 meter per second. Okay. Now another similar question. Another similar question here. Find the velocity attained by a ball dropped from a building mm, just a minute. Hits the ground when dropped from a building. If the ball takes 3.2 seconds to reach the ground and has a uniform acceleration of 9.8 meter per second square. So try doing this question, then I'll give you the second equation of motion. You have to find the velocity with which
Sir, is it 31.36 meter per second?
okay, let's check it out. So you will get the answer as V equals U plus AT. Here V equals U, we know 0, plus acceleration 9.8 and multiply T, which is 3.2. So you need to multiply 3.2 by 9.8.
That is 31.26 meters
Okay.
per
So
second.
we get here 31.26.
26.
Sir, 36.
Okay, let's say 2636 meter per second. Now another question here. So find the time taken by a ball to reach the maximum height if it is thrown vertically upwards and has a uniform deceleration, uniform retardation. Uniform retardation of 9.8. Okay. So try finding out.
Sir, can you mention uniform velocity?
Yes.
Sir, can you please mention a uniform velocity?
Uniform velocity.
Yes,
No, there is no uniform velocity.
sorry, sir. Initial velocity.
No, there is no initial. Yeah, I think we need to give the initial velocity. Yes. You are getting now. Okay. So let's say the initial velocity. mm, it is thrown a velocity of 20 meter per second. Okay, so find out. Okay, so what is the answer?
Sir, 2.04 seconds.
Yes.
Sir, I'm getting 49.
You're getting 49.
Yes, sir.
Sir,
Sir, even I am getting 49.
Okay. So
So it's
for this,
something 2.0.
okay.
Yes,
See,
sir,
this is
2.04 something.
okay. You are throwing a ball vertically upward. So from here, you throw a ball vertically upward with a velocity of 20 meter per second, and it has a deceleration. It has a retardation. So retardation means negative acceleration. We will write here acceleration as minus 9.8 meter per second square. Now, since it is retardation, so if the ball moves up, its velocity will decrease. A time will come when its velocity will become zero. Since its velocity is continuously decreasing, so there will be a time when its velocity becomes zero. Okay. So here I will say that its final velocity is zero. And now I can use the expression v equals u plus at. So use v equals u plus at. So put here v as 0 equals u, which is 20, plus acceleration, that's minus 9.8, and multiply t. So you will get your answer as minus 20 over minus 9.8 as time. Now what should be the answer? So what mistake did you people make?
Sir, we will get 2.04 meter something, sir.
Yeah. So if you divide, we get 2.04. It's 20 divided by 9.8. It's 2.04 second. Now we extend this concept further. Now, what concept we are extending here? We can find out if the acceleration is uniform. If there is uniform acceleration, we can find out the value of average velocity. Okay. See, the average velocity if it is this is applicable only if the motion is uniformly accelerated. So we can find out the value of average velocity, which will be given by initial plus final divided by 2. So can I write the average velocity like this? As the average of two numbers, which are initial and final, since it is uniformly accelerated. So in the case of uniform acceleration, we can find out the average velocity as initial plus final divided by 2. This is how we find out the uh, uh, average, adding two quantities and divided by 2. Okay. So average velocity will be calculated as v plus u by 2. Okay. Also, we know average velocity is given by another formula. The average velocity is also given by total displacement by total time. This was the formula which we studied in the beginning, that average velocity can be taken as average velocity. V bar means average velocity will be as total displacement by total time. Now I can equate both these expressions to get here s by t equals v plus u over 2. Okay. Now transpose t to the other side, you have s equal v plus u over 2 multiply t. Okay. Now here, if we use the first equation of motion, our first equation of motion says that v is equal to u plus at. Okay. So putting the value of v in this expression, we can get s equals u plus at. So see what we have done. We are substituting this v with u plus at. So in place of v, we are writing u plus at.
Or what is S?
S is displacement.
Okay, sir.
Okay. Remember, S is displacement. In the beginning, we said that displacement will be represented by the symbol S. So S is the displacement. So have you understood? We just have replaced this v by u plus at. The remaining
Sir,
everything is same. Yes,
displacement equals to v plus u by 2. Is it 2 or z?
2 v plus u by 2.
Okay, sir.
Okay, okay. This is 2. Here we have written, see, average velocity is given by v plus u by 2. Average velocity is also given by the formula total displacement by total time. Okay. So since both are the formula of average velocity, we equate them. And if we equate them, we get here displacement by time equals to u plus v by 2. By transposing, we take t to the other side, and now we substitute the value of v. The value of v is u plus et. So we put here u plus et in place of v, and we get this expression. Now we can simplify it further. So u plus u would be equal to 2u. Okay. So we'll get here u plus u will be equal to 2u plus at multiplied by t over 2, and here we have displacement equal. Multiply t to the bracket inside, you'll get 2ut plus at squared over 2. Now you can separate the terms, you'll get your displacement equals 2ut by 2 plus at square by 2. You cannot cancel these two here as there is a plus in between. So there are two terms and hence you cannot cancel them. Now you can separate them out, and here these two cancels. You have your final answer as S equals ut plus at square by 2, or we can write it as 1 over 2 at squared. Now this form is called as the second equation of motion. We call this as second equation of motion. So do make a note of this formula, that displacement is equal to ut plus 1 by 2 at squared. Also you need to memorize this also. Okay. So first equation of motion was v equals to u plus at. The second equation of motion is s equals ut plus 1 by 2 at squared. Okay. So any doubts here? I think everyone has understood about the formula.
Yes, sir.
Okay. So we can do a few questions here. Depending on this formula, we can do a few questions. Okay.
Sir, can you please explain the formula again?
Okay, sure. Why not? See, we started with the formula of average velocity. The average velocity is given as v plus u by 2. We can also find out the average velocity by the formula total displacement by total time. Since both of these, they are the formula for average velocity. So we can equate both of them. We can make displacement by time to be equal to v plus u by 2. Okay. So both equate them. Transpose this t to the other side, you get v plus u by 2 multiply t. Now, this one we know from first equation of motion. This is from first equation of motion we get. From first equation we get v is equals to u plus at. So at the place of v, we substitute the value of v. At this place of v, we have written u plus at. So here we write u plus at, just this. Then you have plus sign, then u, everything same. No changes. After this, we came here. So adding these two u and u, there are two u. So you add them u plus u, giving 2u plus at and multiply by t.
Okay, sir.
So after this, again, multiply this t inside the bracket. Inside the bracket, it will get multiplied to all the terms.
Yes, sir.
And here you get 2ut plus at squared. If here multiply t to both the terms, you get 2ut plus at squared. Then the terms can be separated. If you want to cancel this here, you cannot cancel because in the numerator you have a binomial term. Okay. So to cancel this, either you need to take out two common or you need to separate the terms. So we separate the terms here. So by separating, you get 2ut by 2 plus at square by 2. Then these two get cancelled and you have s equals ut plus 1 by 2 at squared.
Okay, sir.
Okay. Anyone having any doubt? Any doubts here? Okay. So we can start with one question.
Can you turn back? I am writing the formula.
Yeah, it's here. And all of you should keep your camera on. I'm not able to turn on camera because certain reasons. So you should turn your camera on. Keep your camera on so that I can see you people working. So try to write down, memorize this formula. Try to memorize this formula. You'll get s equal ut plus 1 by 2 at squared. We will use this formula to find out. Harshit, are you there?
Yes, sir.
Okay.
So done.
Done. Okay. So let's see. We will try to do one question based on this. Okay. Ball dropped from a building. A ball dropped from a building reaches ground in 3.2 seconds. Okay. So find the height of building.
Will you mention the acceleration?
Yeah, acceleration will be 9.8. Whenever any object is thrown vertically or dropped, so acceleration is 9.8.
So I said because of the gravity.
Yeah, because of the gravity, your acceleration will always be 9.8.
Okay, sir.
Sir,
Okay.
so it will be
Sometimes
fixed
sometimes
for,
it's given as 10 for simplicity of calculations, but currently you take it as 9.8 only.
sir, so it will be fixed for almost everything which is dropped down.
Yes?
Sir, 9.8 will be almost fixed for everything that is dropped down, no, sir.
Yes. Acceleration will always be 9.8. So even if I don't give it, you should take it as 9.8. So See, it is dropped. If any object is dropped, it has its initial velocity 0. If it initially it is in your hand, you are dropping it. So you will be using S equals ut plus 1 by 2 at squared. So S would be equals to u, which is 0 multiply t. That's 3.2 plus 1 by 2 multiply acceleration 9.8 multiply t squared, 3.2 squared.
So I'm getting the height as 152.674.
Okay. Okay.
152,
152.
152, 152 point.
Okay. So let's have this. We have 9.8 multiply with 3.2 multiply.
Sir, I'm getting 34.496 like that.
The answer is 50.2. Are you getting 50.2 meter?
No, sir.
See, you can cancel this. You will get here 4.9 and multiply this 4.9 with the square of 3.2.
7.04.
What's the square of 3.2?
7.04.
7.0. So multiply 4.9 with 7.0. Okay, so you are getting 7.0 as the square. It's 10.24. The square of 3.2 is
Yes, sir.
10.24.
Yes, sir. 10.
Yeah, the square is 10.24 and multiplied with 4.9, you get 50.2. Okay. So bye everyone. We'll see some more questions in coming classes.